Today we're going to talk about the MKS SGEN L version 1.0. Now this is very similar to the MKS SGEN L, except now it's 32 bits, so it has an M3 processor that allows you to do 100 megahertz per second. So I'm going to walk you around the board to show you what's on it. First of all, we have our main power. And as you can see, this is where our power supply can either be 12 or 24 volts. And note how I've marked what's positive and negative, being red being positive, black being negative. The next two over are for a heat bed. Then we have extruder 2 and extruder 1. Here we have a fan port. And then we have our stepper ports. We have our X stepper, our Y stepper, our Z stepper, our E0 stepper, and our E1 stepper. Up above them, we have our NEMA connection ports for them. And then we have an external power of either 12 or 24 volts, depending upon what you're using for your power supply. In all these videos, I'll be using 12 volts. Over here, we have our USB connection, our micro SD card connection. Then we have our, what do we call this? Our TFT slot. This may also be used for an LCD. Moving on across, we have our thermistors. We have thermistor 2, 1, and 0. And these can be used for a combination of your bed or your hot ends over here. Here we have our X minimum connection for our end stop, our X maximum connection, our Y minimum, our Y maximum, our Z minimum, and our Z maximum. Then over here we have what looks to be 2 servo ports that are on the board that you can use to connect to. And then we have our LCD connections over here. So we have one LCD connection, which is EXP something, and then I believe the other one's EXP2. It's not real well written over here. We do have a reset button to reset the power on your board. And then we have our external driver pins right here, these 4 pins in black. They're used to connect a second stepper driver. Over here, these 2 green set of pins, they're used for UART, which basically correlate to these pins that we're using here. One is diag, the other one is, well, we'll figure that out in the next tutorial. Over here we have our power supply jumper, so we can basically either power at 3.3 volts or 5 volts. We're going to leave it at 5 volts by default. And then we have more diag pins over here, which may be used for SPI, but they say diag pins in the documentation. So in order to set this up to actually load software, you'll have to use your micro SD inside your micro SD slot over here. And it'll be inserted as follows. But in order to show you how to set this up initially, I have to show you how to do it with a micro SD adapter. So I'm going to show you how to insert this. So you're going to slide it in like so, and then you're going to place this in your computer. One of the first things I want to show you with this board is it comes with a data sheet that I'll leave a link for. This explains everything you need to know about the MKS SGEN L motherboard, and it has all the information that you're looking for about the board. For instance, down here we have let's see, what type of processor, being 100 megahertz, that it's a Cortex M3 LPC 1768. That's going to be relevant in a moment. But before we can actually load Marlin firmware on it, we need to download it. So we're going to download it real quick here. We're going to go to Marlin firmware.org, press enter. Then you're going to click on download, and we're going to download the latest firmware, which is 2.0.x, and it's a zip file. So while that's downloading, we need an integrated developer environment. So what we need to do is download VScode. And so we're going to go to the download for VScode. And in this case, I'm using Windows and it's 64-bit. So I'm going to use the installer right here. So that's going to take a moment to install. And while that's downloading, let me tell you that no one is paying me to do this tutorial. And I purchased the board with my own money. But I will be placing Amazon affiliate links in the description in order for you to buy it if you so choose. So it looks like the download's finished now. So what I'm going to do is I'm going to do a show in folder. And inside here, I'm going to double click on it to install it. So I'm going to accept the licensing terms and click next. Then I'm going to click next again. And then I'm going to click next again. And I'm going to create a desktop icon so that we can get to it quicker. And I'm going to also add it to, let's see, right here. Open with code. And I'm going to click next. Then I'm going to click install. While this is installing, what we'll do is we'll unzip the Marlin firmware by extracting all and clicking extract. And that's going to take a bit of time, so let's go back and check on the installer. So it's finished. So we're launching it. And so what we need to do inside here is we need to go to extensions and click on that and then type PlatformIO. And what we want is the PlatformIO IDE. So we're going to click install. And now we have that installed. Now you may need other things to be installed. There'll be a recommended software list that comes up. If that does, you're more than welcome to install other things. They're probably going to be something along the lines of what we just installed, being your C or C++, IntelliSense, your Git, but I'll let you figure that out on your own. So what we're going to do is, now that it's unzipped, as you can see right here, we're going to go back and we're going to click Open Project. And we're going to go to the Downloads folder. We're going to open up the Marlin 2.0.x, and there's another subfolder for that as well. And we're going to actually open this up. So I need to move this down a little so you can see. So I'm going to open. And while that's opening, I'm going to move this back up a little. So here are our folders. Now inside, what we have is our Marlin subfolder. We're going to open that up, and inside that there's the source folder. And we're going to go to the core folder, then boards.h. Inside boards.h, we're going to search for board underscore MKS underscore SGEN underscore L. And this is used for our board, so we're going to copy that. Then we're going to close out of boards.h. And we're going to minimize these folders. Then we're going to go to pins. And inside here, like we saw earlier, the LPC 1768, this is where our board is defined for its pins. So what you can see right here is we have the pins underscore MKS underscore SGEN underscore L.H. We're going to open that up. And if you scroll around, what you can see is that each one of the pins on the board is defined for the signal pins. So in this case, P1_29 is the X minimum, and I'll show you where that is real quick. So if we're clicking over here, we can scroll down real quick. We can find where the actual pins are defined with our pinouts diagram. So right here we have our pinout diagram, and if you look over in here, we have our end stops. So you can see that X minimum, the first pin is 5 volts, the next pin is ground, and then we have P1_29, and that's how that file correlates. So what I'm going to do is I'm going to close out of this file now that you understand what I'm talking about, and I'm going to go to configuration.h. And in configuration.h, I'm going to do a search on motherboard, and I'm going to replace board_ramps_14_EFB with what we copied just a moment ago. So I'm going to paste it right here. And then I'm also going to change our serial port, in this case, to -1 because it's the first time we're loading it. But I also want to show you some differences when we actually go to Pronterface. So I'm going to do a search on end stops. And what we have here is the end stops outlined for a bunch of different things, but what we're interested is in inverting. So this will actually change a true to a false and a false to a true just by changing the logic. So we're going to pick Y minimum, and we're going to say that it's true. You'll see why in a second I'm doing that. Now, in order to load the firmware, we have to go to PlatformIO.ini to configure it. And as you can see, the default environment right now is for the Mega ATmega 2560. That chipset is not used, but we did find out that it's the LPC 1768. So we're going to type LPC 1768, and we're all set there. So now to compile, there's a couple of places where we can do that. We can do it over here with build PlatformIO. We can't upload at the moment because we're not directly connected to the MKS SGEN L board. But what we can do is we can build it. So there's 2 places to do this, and the other place is up here. And this is for building your environment as well. So let's see if I can find it. It's probably hard to find. So I'm not seeing it just right away, which is okay. So, whoop, there it is. It's build. So I'm going to click on that. That's going to take a few moments, and then I'll explain what's occurring right now, right here. Down below, it's actually compiling, but sometimes it'll find dependencies that need to be downloaded based on the PlatformIO.ini file. And this will build for a few moments, probably about 2 minutes, maybe 2.5. So in a second, I'll show you what we'll do with the build when it's complete. Okay, now that it's complete, what we can see is that it said that it succeeded in one build, and it was about 2 minutes and 46 seconds. So I'm going to scroll up and double check, and it looks like the chipset that we chose, being the LPC 1768, built correctly. So what we need to do is we need to go to the actual source code that we have here, and we're going to go to the platform or .pio folder and open that up, and then we're going to go to build, then we're going to go to LPC 1768, and we're going to open this folder up. So we're going to reveal and explorer, and then we're going to go to the subfolder. And what we're looking for is firmware.bin. So before we do that, I want to show you the actual micro SD card. And as you can see right now, it's blank. So we're going to format it just in case. So I'm going to go to Format. I'm going to do it as default FAT32, quick format, and I'm going to click Start and then OK. So now that that's complete, we're going to go back to the folder. Unfortunately, I have to reopen it here real quick. I'm going to right click on firmware.bin and I'm going to do a send to the micro SD. So inside the micro SD, we're going to just do this for good practice, but you want to add a text document normally with extensions. So what it would be firmware.cur with capital firmware. But in this case, I'm going to skip it to see what happens. So I'm going to remove the drive, and I'll show you how to actually insert this and load it in just a second. I have the SD adapter here. I'm going to remove the micro SD. Then I'm going to place this inside the TF drive or micro SD drive. Now, in order to power it, what we need to do is we need to connect the USB port to it. So in order to do this, we're going to connect the big side to the motherboard over here. And we're going to connect the small side to the computer. And you're probably going to hear a beep. And what you can see over here is that this flashing light is talking about loading. Looks like it's completed. So we're going to open up Pronterface. Before we open up Pronterface, I just want to show you that it converted the firmware.bin into a firmware.cur file or cursor type file. So we're going to open up Pronterface now by going to our desktop in this case, going to print run, and then Pronterface. So we're going to connect to the board. And as you can see now, it says connecting and printer is now online. So to confirm that we actually loaded firmware from our build, we're going to do a M119 check the status of the end stops because we modified the Y end stop and see what happens. So as you can see, the other two end stops have nothing connected to them, as well as all three of them. But this one says open because we inverted the logic. So if you like my tutorial, please press the like button and subscribe. And thank you for your time.